Welcome to Namibian online classes. Today we are going to focus on waves. The objectives of today's lesson is that by the end of today's lesson you must be able to define the following terms: pulse, oscillations, wavelength, amplitude, frequency. And lastly, you must be able to distinguish between transverse and longitudinal waves. Let's start by defining what is pulse. A pulse can be defined as a single disturbance in a substance. While it's an oscillation, it is a repeated to and fro motion of a fluid or elastic solid, e.g. a stretched string. The wave motion is a means of transferring energy from one point to another without there being any transfer of matter or substance between these points. There are two types of waves. One is called longitudinal waves, and two is called the transverse waves. Longitudinal waves, the pulse is parallel to the direction of wave movement. While the transverse waves, the pulse is perpendicular to the direction of wave movement, as shown in the diagram below. You can see that the transverse waves, the pulse is perpendicular to the wave movement. But if you look at the longitudinal wave, you can see that the pulse is parallel to the direction of wave movement. Right. So to further explain the difference between transverse waves and longitudinal waves, like we said that a pulse is a single disturbance. I want you to notice what is going to happen in this diagram. Here it's a string that is attached. So here we are going to disturb this string here at this point. So I want you to see the single disturbance that occurs when a pulse is started. So if I start a pulse like that, you can see that as I did a single disturbance, the wave moved along the string, releasing energy to each and every particle along the string. So that was the first pulse. Let me do another pulse. Look at that. That's another pulse. A single disturbance to the string. Another pulse, which is the third pulse now. There it is. That's a pulse, and that's a wave of a pulse. In a slow motion now, I want you to see what a pulse is there. That's a single disturbance, and the wave moves, and that's a pulse. But when we talk about oscillation now, these are repeated pulse. If we repeat the pulse, we have what we call oscillation. For example, look at the oscillation, these ones. That's an oscillation. The pulse has been repeated. So a repetition of pulse, we call it oscillation, because there are more than one disturbance on the substance. So we call it a what? An oscillation. Right. So that's an oscillation and that's a pulse. So what we are saying is, again, when we talk about a pulse, we are referring to the single disturbance. So I want you to watch as I'm going to disturb this again. That's a single disturbance and that's a pulse. But in oscillation, these are more than one pulse, like this. That's an oscillation now, more than one disturbance. So we call it oscillation. Right. So now let's take a look at what happens. So in transverse waves, it moves parallel or perpendicular to the direction of wave movement, whilst longitudinal waves, they move parallel to the direction of movement. This can be seen as follows. So we are saying when you look at the transverse waves, if they are having a high amplitude, their crests and their troughs, their crests will be high and their troughs will be low. So when we talk about transverse waves and their amplitude, a high amplitude on a transverse waves simply means a higher crest. So if you look in our diagram, you can see the crest, which is the top part of the wave. So a high crest simply means a high amplitude, and a lower troughs simply refer to a high amplitude. On the other hand, if you look at the longitudinal waves, they have a high amplitude if their region of compression is crowded, whilst their refractions is spread out. So where they have a compression, this part, where there is compression, it will be crowded. So if they are crowded like this, it means that we have a high amplitude on the longitudinal waves. And also this part is what we call the refraction of the longitudinal wave, referring to the difference or the distance between the two compression points. So a high amplitude on a longitudinal waves can be simply seen by a crowded compression. So if you look again on this diagram, you can see that if we talk about the wavelength, we are talking about the distance between two crests. That's what we call a wavelength. And this top part of a wave, we call it a crest, while it's the bottom part of the wave, we call it a trough. And the point where we have a one complete cycle, that's what we call one wave. So a wave is simply represented by a one complete cycle. So a cycle starts from the equilibrium, going up to the crest, back to the equilibrium, going to the trough, and back to the equilibrium. While it's also an amplitude is represented by the height between the crest and the equilibrium. So the frequency is the number of complete waves generated per second. The unit of frequency is cycle per second, and it's also measured as hertz. And the wavelength of a wave, represented by the Greek letter lambda, is the distance between the two successive crests and troughs. And the amplitude, represented by letter A, is the height of a crest or the depth of a trough measured from the center of undisturbed position. And the time period T, it is the time taken for a wave to complete one cycle or one wave. Therefore, the wave equation can be simply written as the speed of wave is equals to frequency times wavelength, where T is the time period of the wave. Now, try these exam questions. A drop of water from a tap falls onto the surface of some water of constant depth. Water waves spread out of the surface of the water. Which statement is true? Attempt this question and send me the answer. Another question. A student measures how far a cork moves up and down on a wave in a tank of water. Which quantity can he obtain from his measurement? Attempt this question and send me the answer. Another question. Waves are sent along two springs, X and Y, as shown. How should the wave motion in X and Y be described? Attempt the answer and send me the answer. Next question. The diagram shows a cork with a weight attached so that the cork floats upright. Transverse waves travel across the water from X to Y. Which way do the waves make the cork move? Attempt this question and also send me the answer. The diagram shows a wave. How many wavelengths are there between X and Y? Attempt this question and send me the answer. The diagram shows a section through a series of waves on water. Which dotted line shows the position of the still water surface after the waves have passed? Attempt also this question and then send me the answer. The diagram shows example of waves. Which are longitudinal waves? Attempt this question and then send me the answer. The drawing shows a wave. Which labeled distance is the wavelength? Which labeled distance is the wavelength? Attempt that question and also send me the answer. Which waves are longitudinal waves? Light waves from a lamp, microwaves in an oven, sound waves from a trumpet, water waves on a pond. Then lastly, what is the unit of wavelength? So thank you very much. And for more information, please contact me on 0818-506-486 or visit our website www.atkins.today.